Our final tutorial for the topic of depreciation is the unit production method. In this tutorial, we will do calculation on this company Alfin, and they need to depreciate its existing capex based on the ratio of its annual production to its reserves. And you are given a table of its annual production, and its capex is $100 million. So you are to just fill in the depreciation values for the company. Okay, so let's recall what is the formula for unit of production method. In a unit of production, you calculate according to the actual usage of the asset. If the activity is high, then you have a high depreciation. And if you don't have any activities, then the depreciation is just zero. So unit of production is quite similar to the straight line method, but instead of the life in years, you do it in based on its number of operations. Or when we are talking about oil reserves, then it's the number of recoverable reserves. Now the formula for the book value or the year-end value, AN, is equals to the initial cost multiplied by 1 minus P is the cumulative production divided by the recoverable reserves. Now let's get back to that table just now. So the table provides us with values of its reserves from year 1 up to year 5. Alright, and first the reserves is 40, and then it starts to decline to 36, 26, 16, 7. This is because its production, it's 4. I'm guessing this is 4 million. This must be million barrels game. It's 4 in the first year, and then 10. So therefore the reserve depletes, and 10 third year, 9 in the fourth year, and 7 the fifth year. So if you total it up, the total production is 40, which is equal to its recoverable reserve. So since in the formula we need to have P, which is the cumulative production, so we will calculate the cumulative production first. Okay, so for the first year, production is 4, and therefore in the second year the cumulative production will be 14. The third year is 24. The fourth year is 24 plus 9 is 33, and fifth year is 33 plus 7, which is 40. And now, just to make it easier for our calculation, let's just do the calculation for P over R. So P over R would be 4 over 40 equals to 0.1. So do the same for second year. P over R is 14 over 40. So remember, it's always with the recoverable reserve. And then year 3 is 24 over 40, which is 0.6. Year 4 is 33 over 40, which is 0.825. And finally, the fifth year is 40 over 40, and you get 1. So that's the P over R. And given that the capex, or the initial cost, is $100 million, so the year-end value, we use this formula. So the year-end value would be 100 times 1 minus P over R, which is 0.1. So 1 minus 0.1 is 0.9 times 100 equals to 90. And do the same for the rest of the years. And you will see that at year 5, the year-end value here is 0, similar to what you will get with a straight line method. And you can also calculate what is the depreciation every year. You will see that depreciation for the first year is 100 minus 90 is 100. And for the second year, the depreciation is 25 now, because you have to minus it. And then the third year is also, the difference is 25. And then fourth year, the difference is 40 minus 17.5 is 22.5. And then finally, the 5th year, the depreciation is 17.5 minus 0 equals to 17. So you see here, the depreciation now does not have any kinds of patterns like declining balance or the straight line method, but rather how much depreciation would depend on the activity of that operation. In this case, it's production. The higher the production, for example, the highest production is 10, so therefore the depreciation is highest. So the lower the production, for example, the lowest production is 4, and therefore the lowest depreciation is in the first year. And that is how you solve a problem using unit production method. Okay, so before we end, here is an additional tutorial for you to do. Apply and sketch using methods of straight line method, 25% declining balance, and unit production depreciation scheme to calculate the capital allowance for a project that is given in this table. And given that the total capex is $150 million. So good luck, and I'll see you again.